Assalamu alaikum, my dear students. Welcome back again. Today our topic is conservation of linear momentum. And according to this law, conservation of linear momentum, it says when two or more bodies interact with each other, and if there is no net external force acting on the system, the total linear momentum of that system remains conserved. In other words, it says for an isolated system, the initial linear momentum of the system is equal to the final linear momentum of the system. Okay? And now let's prove this statement. And we know that momentum P is equal to mass times velocity. Okay? This means that if there is no velocity, momentum will be 0. Okay, and there must be the velocity of the object in order to maintain the momentum. So we will understand here with the help of an example. Consider two objects. If this is object A and if this is object B, and this object has mass m1, this object has mass m2, and consider this object moving with initial velocity u1. Okay, if this is moving with initial velocity u1, and this object is moving initially with velocity u2. Okay, this is the initial velocity of object A, and this is u2 is initial velocity of object B, and these velocity are such that u1 is greater than u2. This initial velocity u1 is greater than u2. This means that these two objects will collide at one point. Okay, these will collide at one point because this object is moving with greater velocity, and this object is moving with slower velocity. This means that if they are moving in the same plane and in the same line, so they will collide each other. And when the collision takes place, let that collision remains for time t. Okay, let that collision remains for time t, and let this. Now, when the collision takes place, this object will impart a force on this object, and this object will impart a force on this object. Okay, according to Newton's third law of motion, to every action there is an equal and opposite reaction. If this interacts with this, so this will impart a force on this, and this will impart its force on this object A. So let F be A. Let F be A is the force exerted by A on B. Okay, it is the force exerted by A on B. And let FA be. This is the force exerted by B on A. This is FAB. Okay, force exerted by B on A. So if this was the collision, okay, and this is m2, this is m1, this is object A, and this is object B. So this is collision. Okay, and after the collision, these objects will separate. Obviously, these they will not stick to each other. They will separate after the collision takes place. So let their final velocity be. Let their final velocity be. This is v1, object A, and this is v2. Okay, this is object B. So this is m1 and this is m2. So its final velocity is v1, object A, and object B velocity is B final velocity is v2. So there will be a change in momentum. Okay, after the collision there will be a change in momentum of object A, and also there will be a change in momentum of object B. Okay, so the change in momentum of object A, change in momentum, let me rub this. So change in momentum of object A. What is the change in momentum? Change in momentum is mv, okay, final momentum minus initial momentum. What will be its final momentum? Its final momentum will be mv, okay, m1 v1. Here it is m1 v1, okay. So this will be m1 v1 minus what's initial momentum? Initial momentum is m1 u1, okay. So its change in momentum will be m1 v1 minus m1 u1. This is change in momentum. So I can write it as m is common here, m1 v1 minus u1, okay. This is the change in momentum of object A. And change in momentum of object B, I can write change in momentum of object of B is equal to m2, it is similar just like here, m2 v2 minus u2. So this is change in momentum of object B, m2 multiplied by v2 minus u2. So let me rub this. So during the collision, as the body A imparts an average force equal to FBA, which I have shown here, that is FBA, okay. That is the force which body A imparts on body B, okay, on B, and FAB is the force which is imparted on A due to force due to body B, okay. And according to Newton's third law of motion, Newton's third law of motion says that to every action there is an equal and opposite reaction. So this force will be equal to this force, okay. The force exerted by body A body A on body B will be equal to, but in opposite direction, will be equal to force exerted on body A due to body B, or force exerted by body B due to body A, okay. So according to Newton's third law of motion, it says that to every action there is an equal and opposite reaction. So this action will be equal to this reaction, okay, but in the opposite direction. So FBA will be equal to minus FAB. So now according to the mathematical definition of force, we already know that if I can write this as FAB. This is the force imparted by A on B, okay. So the mass of the object A has got mass m1, okay. The mass of the object has m1 mass, and its acceleration is a1. So its acceleration will be a1 because F is equal to ma according to Newton's second law of motion. So this is simply equal to, this acceleration is change in velocity, okay. Change in velocity divided by time. Acceleration is equal to change in velocity divided by time. So change in velocity of object A is equal to v1 minus u1, okay. This is final velocity minus initial velocity, as we have seen, divided by t. So and similarly FBA is equal to m2a2, which is equal to m2 multiplied by v2 minus u2 divided by t. So if we substitute this value in this equation, we will get m1 v1 minus u1 divided by t is equal to minus m2, because here it's minus, okay, minus m2 v2 minus u2 divided by t. So we will get this. T and T will get cancelled here. So we will get finally M1 U1 plus M2 U2 after rearranging. Okay, this is M2 U2 M2 V2 here. So here it's M2 U2. Okay, so this is here M1 U1, but this is minus M1 U1 here. I have transferred it to left hand side, and here in the left hand side it is M1 plus M2 U2. Okay, so I have written this. So after rearranging, I will get M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. So this equation, as we get, this equation gives the idea of conservation of linear momentum. Okay, if you look here, this M1 U1 plus M2 U2, it represents the total momentum of object A and B. This is total momentum of object A and B, but this is initial momentum, because here it is U1, here it is U2. Okay, so this is the initial momentum of object A, this initial momentum of object B. So M1 U1 plus M2 U2, that is total initial momentum of object A and B is equal to the final momentum of object A plus object B. So so the initial momentum of two objects is equal to the final momentum of two objects. That means the linear momentum is conserved. So this represents the momentum of object A and B before collision. Okay, and this represents the momentum of object A and B after the collision. This means that the total momentum before collision is equal to the total momentum after collision. So I can write in conclusion that total momentum before collision is equal to the total momentum after collision. So this is the law of conservation of linear momentum. So in conclusion, we can say that when the two objects, okay, when the two objects, suppose this object A and object B, when these two objects are subjected only to their mutual interaction, okay, if they are subject to their only subject only to their mutual interaction, this means that if the external force is not there, okay, and so this system is called isolated system. The system where external force is absent, this means that external force should not be here. So there should be only their mutual interaction, okay, and external force should not be there. So this is called isolated system, when the external force is not there and the objects are subjected only to their mutual interaction. So the sum of momentum of the bodies remains constant in time. This means that sum of the momentum will remain constant in time. Okay, and this is only true when there is no net external force acting on the system. Okay.